Well, we have a very rich afternoon going from one extreme to the other. The oldest goal, I think, that you really have if you take a look at the history of flight, the oldest goal was really achieving the bird capability, the capability to take off, to hover, to fly, to land as you saw fit. This was something that certainly goes back into the dawn of early flight. Indeed, the earliest aerodynamic flying-powered device that we saw created was the drawstring helicopter toy. And you can look at medieval church paintings, and you actually see pictures of the Christ child depicted holding a drawstring helicopter toy, which indicates how very early that people were thinking about the safety problems of rotary wing aviation. Now, that was a cheap shot. It shows that God himself ordained rotary wing flight. So here we are. We have with us today an extraordinary panel of individuals who have explored rotary and VSTOL flight in all its attributes, with helicopters, with converter planes, with vectored lift thrust, tilt rotors. I think we have a rich dish here for you. We also have, coming very rapidly up behind them, a panel on the space shuttle, and we want to be fair, certainly, to that panel that we don't run over time. So we're going to have a slightly different rules of engagement for this panel than we did for the previous one. The slightly different rules of engagement here that we're going to have presentations that would be between 7 and 8 minutes by each of our guests so that we don't run over. I would like to take these presentations in roughly chronological order in terms of the work and the development that was undertaken in VSTOL flight after the Second World War. And so I'd like to start, first of all, with Bob Ferry, who's a fellow of the SCTP, and his work on the XV-3 tilt rotor. Bob Ferry did remarkable work on this vehicle, the XV-1, the XV-3, the XV-9. He's the only pilot who flew all of those converter planes, a USAF TPS graduate. For some reason that I have yet to fathom, he decided to fly a Hughes OH-6 nonstop from Los Angeles to Daytona Beach. It must have been a wild beach weekend, and it must have taken forever to get there. But that's thanks to Bob, we developed the technology base that we now see exploited. We saw exploited in the 1970s by the XV-15, and that we see now being exploited by the V-22 joint service aircraft. So Bob, we welcome you to the panel, and would you please give us your thoughts on the XV-3?
Thank you. I was assigned as a project test pilot on the XV-3 in about 1958, and so I went to Bell to confer with them on how we would conduct testing. And they said, we can't test it at all because we don't have any money. So I said, well, you've expended it all, and who do I see to do something about this? And they said, well, there's this colonel, an Army colonel at Wright Pat. He's the one that controls the purse strings. So I went to Wright Pat and talked to him and convinced him we should have the aircraft for 90 days, and that would be it, the cutoff. So the test started first in Fort Worth. I did the hovering and cyber flight and low speed stuff, and the rains came, the Texas spring rains, so we couldn't continue testing. So we got a C-130 and bundled up the XV-3, put it in, went to Edwards, where they immediately started to instrument the aircraft. In fact, they put so much instrumentation in it, it was so heavy it wouldn't hover. So we put ground handling wheels, about 10, 12-inch diameter, double ones, fore and aft on the skids. And that worked out pretty well. In fact, I did an auto-rotation landing. Although it wouldn't hover because it's so heavy, I managed to do an auto-rotation landing, power off, which if you check with any of the helicopter pilots, when you're that heavy, it's pretty hazardous doing the auto-rotations. But it had a span-wise lift distribution, very favorable. In other words, an aspect ratio that was good because the two rotors laterally displaced in forward flight would assume one envelope of air. And so even though you couldn't hover, short ground roll, say at about 15 knots, lift off and climb right on out. So we really had no trouble with that. Now, the XV-3 had a R985 engine, 450 horsepower, which is underpowered, but that's what we had to work with. And as a helicopter, it functioned just like any helicopter, any tandem helicopter, with the controls. But then, of course, you have to get into forward flight, and you tilt the rotors down to airplane propeller configuration. That seems pretty straightforward, but hovering, it usually requires about 13 degrees, 14 degrees of pitch on the main rotor blades. And in forward flight, the efficiency is something like 44 degrees. So the collective pitch, when you pull it up to get that much pitch, wasn't enough. So they put in what they call a range shift, electrical switch. You could beep more collective into it. So then you would have to shift gears too. They had not only a range shift, but gear shift. That's just like in a car where you have the clutch, you cut the foot feed, cut the power, and change the collective to get the low rotor speed so you can get the high RPM, and then come back with power. That all took about 1,000 feet of altitude to do. And it was very complex. In fact, when I first started flying, I went to the wind tunnel at Ames, 40 by 80, and they put the bird in there, and I got in the cockpit and operated it in the wind tunnel. And as I understood it, that was the only second time they ever had a man in the craft in the tunnel. And sure enough, later, they were doing some more work in the tunnel, and it broke loose and went sweeping on down the tunnel. So that the danger for a man is obvious, and the fire department couldn't get to that anyway. So I probably didn't appreciate the danger of that too much being young. In fact, Bill Quinlan, the company pilot for Bell, was supposed to do that, but he said when it came time, he said, "Bob Ferry can do it. My wife's coming in and I got to go pick her up." I guess that was true. I don't know. Maybe he didn't want to do it. But the complex switchology in the cockpit is changed, I'm sure, on the later versions. But it was in fact, in the tunnel, when I was operating the rotor from hover back to forward and gear shifting and changing, I wondered if I lost an engine, would I be able to do all that? Because let's say you lost the engine in airplane configuration with the prop. The prop extended well below the landing gear, so that if you came in, you wouldn't have a chance on that. So you had to come out of the high ratio and on the gearing, and then reconvert the rotor to the hover position, and hope you had enough altitude to do it. So our tests were considered pretty satisfactory. The society gave me the Kinchlow Award for it. I thought that was nice of them. And I think NASA took it then and flew a few flights on it. And then it kind of got snowballed, but nothing much happened for a while. But I think it paved the way for the XV-15 and the B-22, the other tilt rotors of note. Actually, the original design, it came from an aircraft company called Transcendental on the East Coast. They built 3 aircraft. They had mishaps or crashes, and they ran out of money. So Bob Lichtman, who was the chief engineer on that project, moved to Bell and took the design with him, and they entered a competition for building a rotorcraft that would haul 1 litter patient plus the pilot. And McDonnell Douglas had the XV-1, that was it, an unloaded rotor. the V2 was supposed to be a Sikorsky entry, but it never got off the drawing board. And then the XV-3 is the one I've been describing. So it seemed to me it had a lot of potential. The low-speed handling wasn't so good. It had a roll oscillation and hover. It had a directional change. It had some vibration. All of these, I think, probably could have been improved or fixed. And I managed to fly it, so I guess others could too. I flew all the tests except one. Walt Hodgson flew one of the, and he was usually my chase. Every time, to save time, and every time I climbed up to altitude, we'd use a different conversion angle. You could fly it at any conversion angle within that 90-degree range. And to get all the data, we just changed it every time. So we had a big carpet plot of conversion angles. Another unsatisfactory thing was the downward ejection. And all that was bungee cords on your seat that if you open the doors, you'd get, I asked them, I said, will this work? And will a guy get clear of the aircraft? They figured about halfway through.
Yes.
That's how far you get.
Yeah.
So I had no intention of using a downward ejection after that. But money was scarce, time was scarce, so they did what they could. And of course, under modern technology, they would make everything automatic for conversions and range shift that would be built in. But it was a R985 restiff engine, and it didn't have the range to maintain power on the different propeller settings.
That's really interesting when you look at what was being attempted at that time. When you think of the state of aviation technology, this is before we were really able to apply the turboshaft to rotary wing vehicles, before you really had the materials revolution then of the late 1960s that started to come in. The R985 he refers to as a classic radial engine, perhaps best remembered for having powered the Beech 18, one of the classic transports of the 1930s. This is really an example of taking leading thought about where people should go in the VTOL business and then kludging together available technology to make it work. And it really, once again, I think, exemplifies the character not only of the research that was going on, but the character of the people that were undertaking it. Now, in the interest of time and other rules of engagement, I'd like us to hold our applause until this panel finishes. But Bob, we appreciate very much that enunciation that you gave us. And I think now as we go through the rest of the panelists, we'll see that this field, as it evolved, people were faced with a variety of configuration choices, and some of the other vehicles and configuration shapes that they chose and some of the experiences they had were quite remarkable. And certainly none more so than that experienced by our next speaker, Stanley Kakal, who flew the Bell X-22A. Distinguished record as a naval aviator in World War II and Korea, a man who has touched most facets of aviation in one way or another. He's been an airline pilot, engineering test pilot on a wide range of aircraft types, light transports, and then all the way into the VTOL business. And the most exotic, clearly, of the projects that he was associated with, and the most, certainly the most fascinating, and I dare say probably the most daunting, was the Bell X-22A. An associate fellow of the SETP, Stan, you have the stick.
Thanks for the intro. I guess you've got my autobiography there.
Yes. Yeah.
I joined Bell actually Bell was interviewing a whole slew of pilots for the X-22 program, and somehow my name got thrown my hat got thrown in the ring. At the time, I was the chief pilot for the General Electric's Mississippi test operation. Previously I was an engineering test pilot out of GE's Flight Test Center in Schenectady, and that facility was about to close, and I got promoted, got to be the chief pilot of Mississippi test operation, but I still had the end for the flight test business. Like, ever since I was a kid in the 6th grade, I wanted to be a Navy pilot, a Navy test pilot, an airline captain, and aspired to the rank of Navy captain, and I was in the right place at the right time. Anyway, Bell asked me to come on up for an interview. A gentleman by the name of Slim Russell, ex-Navy captain, he's instrumental in a lot of the Navy carrier landing systems, interviewed me. And he took me over to the executive dining room and chatting just casually, asked him, "Where's the airplane?" About that time, a mechanic came by with a handful of rivets, and he said, "He's carrying it." So that was my introduction to the X-22 program. I saw pictures. Joe Cannon had delivered a technical paper, I think, a year or two before on the X-22. And so I knew something about the airplane. And we proceeded in orderly interview, talked to several VPs, VP of Engineering, and I went back to Biloxi, Mississippi, where I was living at the time, working for the Mississippi Test Operation. And about two weeks later, I get a telegram and said, "Come on up, we've got a job for you." I was in the process of buying a house. I said, "Geez, I'm buying a house." They said, "Cancel it." So I quickly terminated the purchase contract and paid the penalties, went to Buffalo, and had Mississippi license plates on my car. Well, that's just when the race things was going on, and I was driving around looking for a place to live, and one of the neighbors in the area that I was looking at called the police and said, "There's somebody here's a rabble-rouser with Mississippi license plates trying to excite everybody." So they stopped me, pulled me over, and I explained the situation. He was very apologetic and nice, and she said, "Sorry about that." And I said, "But get the license plates changed as soon as you can." So, but anyway, the airplane, we were very instrumental in observing the airplane being manufactured in the production hangar, and it was being built under the PERT program, Program Evaluation and Review Technique, and something wasn't done on time, well, we'll catch it at the end of that particular program. So a lot of the stuff wasn't done until after the airplane rolled out of the production hangar, and we got it in the flight test, and it took about a year from when it was left the production facility over to the flight test hangar before the first flight. In the meantime, courtesy of Jesse Jacobs, two of us had the opportunity to fly the XC-142 out at Edwards to get an idea of what the ground handling and the flight characteristics of the XC-142 prior to our first flight. And we also had the privilege of going to NASA Ames to fly their 6th degree of freedom simulator with all of the flight control laws programmed and for vertical flight, and that proved very, very good in performing the first flight. And on St. Patrick's Day, the morning of St. Patrick's Day, 7 o'clock in the morning, that was the day we were going to have our first flight. And beautiful, nice day in Niagara Falls, and everybody was out there, including all of the project people. The Vice President of Engineering, our boss man wasn't there. He was doing business in Washington. And we rolled out and started up the engines, taxied out. I didn't know it. First time I ever moved the airplane under its power. Even though we did run-ups ground, but we were always shackled to the ground. And we taxied, and we had no nose wheel steering. And I didn't know whether I could turn the airplane around in the confines of the runway and the taxiway. So I told him I was going to turn around at a taxiway at the end of runway 27 there at Niagara Falls, and finds my surprise I could turn it very easily just by using differential beta with the rudder pedals. It was a very complicated mechanical computer that governed or disseminated the controls to the elevons and the beta, the pitch control system for flight, from vertical to quasi duct angle positions to horizontal flight. So we checked out the instrumentation, everything worked properly. We went back, shut the engines down, they checked the airplane for leaks and stuff, they climbed back in, and I had no qualms about flying it at all. And I said, "Okay, we're ready," and I came up on the collected pitch, and in about 30 seconds, I knew how to fly. I was already educated. The airplane had a mile, one cycle per second in roll, and it was attributed to the fact that the stability augmentation system was not optimized for the control system powers we had. But be that as it may, it was very easy to handle. The power control mode was or the speed control mode we used it with the collective. It was very difficult to handle. It was sitting back here, and I couldn't use my knee to prop it up like you could in the helicopter. And the friction control is back here, so it's very difficult to let go of one thing and hold on at the same time. So the height was very difficult to maintain the height. Let me put it that way. But the test card called for 3 or 4 landings, familiarization and hover, left turn, yaw to the left and one to the right. In the meantime, I made a couple of landings. Ground effect bothered me a little bit, so I rolled it forward at about 5 knots, and it's perfect. They said I could have landed on a bunch of egg crates and not broken any eggs. It was that easy, that's how soft the landings were. So I made 3 more, and coming up on 10 minutes. We were limited to 10 minutes because the propulsion system was not qualified, 50 PFRT required by the Navy, and made the 90-degree turn, and it would have taken us over 10 minutes, so I completed the 180-degree turn and landed and taxied back, and better believe St. Patty's Day, right? Green beer flowed after that. We all had a big party, and but then the program was laid up until after the PFRT of the propulsion system was completed and the flight control system. We had extensive experience in operating both of them, and that certainly contributed to the confidence we had. We did have some failures, and I'll explain that as we go on a little bit. The second flight was aborted because we had a problem with our one channel of the stability augmentation system. But the gains were set properly, and it was a very easy liftoff and very, very stable airplane, and I knew now how to handle the collective pitch with the friction, and I did my best to kind of keep the collective pitch set so I wouldn't yo-yo the thing. And it was a very successful second flight, except we had to abort because of the failure of the SAS system. And the third flight, we did the same things, repeated what we did on the first and second flight, except started to expand the envelope laterally 35 or 5 knots laterally in one direction, and the other direction forward 5 without rotating ducts. We still hadn't been cleared to rotate the ducts in flight because of a problem with the propulsion with the flight control system test stand. After we qualified the flight control system, we were now able to rotate the ducts, and we started to rotate the ducts, and going forward about 35, 40 knots, a very gusty, windy day at Niagara Falls, and we ran in this duck buzz. It's similar to running on the rumble strip of a superhighway with the freeways, about 120 cycles a second, my calibrated backside told me. So I stopped, but in the meantime, the airplane started to sink because we had disrupted airflow through the propeller ducts, and we were stalling the tips of the propeller blade, and that was causing the 3 per rev vibration. And it was not alarming, but it was concerning because all your nose started to twitch. You have the hairs in the nose itch, and you can't let go to do anything. So we put it down, and the telemetry showed that we had high vibes on the prop center body. So we went back to the hangar with the airplane. Engineers looked at everything. They said, well, we have to find out what's the cause of it. So they instrumented the airplane, and we went and duplicated the thing and experienced the same sort of vibration. They found that that's what was the cause, decided to put wing-type vortex generators on the leading edge of both the front and the rear ducts and to smooth the airflow out. And on a later flight, we did confirm that contributed to the reduction of the vibration. It didn't completely eliminate it, but it was within structural limits of the propeller center body and the rest of the airplane. Little did we know that it was exciting some of the hydraulic lines. We started STO type flying, and we chose a 30-degree angle of the ducts to do the flight. This is all based on telephone conversations and conferences with the Navy, and I made a 30-degree duct angle takeoff, and just very smooth, no pilot-induced oscillation. We circled the field one time, about 500 feet came in. They asked me where I was going to land, and I said the intersection of the taxiway and the runway. And I had such good control, I landed about 10 feet past the intersection. This is the first landing in the STO. We then continued to expand the envelope in the bank third stick force per G stuff, and we were cleared for our first full transition from horizontal to vertical flight and back, and this was Flight 15. We did the preliminary work from 0 to 30 and 35 to 40, and then also from 90 to 60, and now we're going to close the loop, and we're going to do that on our first transition. As I started to rotate the ducts from 60 degrees down, the chase airplane observed red fluid coming out of the back end. About the same time, I had a caution light come on saying I'm losing hydraulic power from the primary hydraulic system. I immediately terminated the flight, so I headed back for Niagara Falls, and started to come on down. We were about 5,000 feet at the time, and it was kind of hazy in the Niagara Falls area that day. I believe it was sometime in June, July, something like that. August, as a matter of fact. And I headed back for Niagara Falls. I got the caution light come on again, saying I'm losing the secondary system. So I headed right down to the field down below, and I didn't want to roll it on because we had the kiddie car landing gear. And I was afraid if I rolled it on, it would cartwheel. So I decided to make the full transition. In the meantime, I was out of the envelope for a 90-degree duct angle landing with the speed I was doing, based on the fact that we knew we had duct buzz at 40 and lost the lift. But I didn't care. I was coming down and going to land it. And about the time we got to the 90-degree position, we were still doing about 15, maybe 20 knots. The controls locked up, lost all of the hydraulic system. In coming down, my co-pilot wanted to eject. And I said, no, I still got control. And we hit at a sync speed between 20 and 30 feet a second. They exploded the oleos. And it flexed so hard that one of the drive shafts of the rear propellers decoupled and twisted its tail off. My co-pilot got out right away. I stayed in the airplane because the engines were still running. I shut the engines down. I pulled all of the emergency shutdown handles, pulled the throttles back for the shutoff. Nothing happened. I couldn't do anything. I didn't realize that the tail had twisted off, and here I was sitting, so I finally decided, well, I guess I better get out of it. So I egressed, and as I got out, the parachute clipped my leg, and I fell down and looked back. I said, where's the tail? And no tail. That's what happened. It decoupled and it twisted its tail off. And I presented this as a technical paper on the 10th symposium, I believe, and it says that we have the videos of all of this, so that I believe the society has a copy of it. It was a very, very interesting program. After the number one airplane, it was destroyed. Really, it was pilot junk, except for the cockpit. We proceeded with the number two airplane, had a very successful flight program, and due to the fact that the number one airplane was instrumented fully for structural and aero demo, and the number two airplane wasn't, it was the variable stability airplane. The Navy wanted a 200-knot airplane, so we had to demonstrate 220, the 10% over. And we did that and completed all of the aero work and the structural work that we were, with the limited instrumentation that the airplane had. And the airplane was then laid up for a major inspection. In the meantime, we got a new boss because my boss got fired because he didn't hang around after the accident. And I asked the Vice President of Engineering, how about getting the job as the Chief of Flight Test? I was already the Chief Engineering Test Pilot, Chief Experimental Pilot. And he said, well, Paul Emmons, who was a very, very good engineer, I would no question, good, excellent credentials, MIT grad, did a lot of work on the X1 and the X2 airplanes. And he got the job, and well, I told my boss, in the meantime, I had a job in my hip pocket. You don't quit a job unless you have a job in your hip.
That's fascinating. We, unfortunately, we're at the point where I think we need to move on in the program, but thanks to your work and the difficulties you faced in the number one machine, that VSTOL aircraft later became, of course, a major VSTOL resource and was used for years as a variable stability trainer. So it really showed the benefits of the very careful and incremental testing that you and your colleagues did early on. Very good work.
We did a thorough job within the funds that were available to us.
Indeed. I'd like to move on now to another kind of vehicle, a very interesting vehicle that might well have been, if you will, the Apache of its day, and that's a program many of you may have heard of called the Cheyenne. The presenter here who will be talking about his experience with VSTOL flight, including the Cheyenne, is Don Segner, a remarkably versatile airman, Lockheed test pilot, fellow of the Society, a man with a very interesting background in aviation. He was a Marine pilot in Korea. He was flying F-9F Panthers. He was flying Corsairs. Then he got an assignment with the United States Air Force flying F-86 Sabres, and then he made the mistake of learning to fly a helicopter, and from that point on it was kablam, V-stall from that point on. A remarkable range of experiences in the rotary wing world, graduate of the U.S. Navy Test Pilot School, established a speed record in the XH-51 rigid rotor helicopter demonstrator, 300 plus miles per hour, and of course most noted for his work on the AH-56 Cheyenne, a remarkable flying machine with an unloaded main rotor and with a pusher prop as well. Don, over to you.
Thank you very much. I will talk about those speed things. But the main thing is that I don't like helicopters. My company has 155 helicopters and 16 fixed wings, and I've never liked helicopters because they don't fly right. And I can tell that to Jerry Wood. I took him up in an HR-2S once, and I showed him what an unstable aircraft was, how we became the rate damper, how there's no stability in those things at all until we get electronics, and we didn't have electronics in. Now, you got to remember this area we're talking about. We didn't have PCs. We didn't have computers. We had smart men who were willing to take chances and gamble and look at things and do things the way they should. Now, look at Stan Kakel. He was flying T-53 engines. No, what was it? T-58, right, Stan? T-58. And I was flying him in the H-21s for the Army when he was the contractor test pilot. I did the first Navy testing, although I was a Marine, in the HSS-2. Stan was down doing some engine tests in the HSS-2. Now, I had a lot of engine failures, but I got them all down. Stan's the only guy I know that had an engine failure out over Key West, and the HSS-2 is the one the President flies in now. That's called, what do they call it, the SH-3A or something. Right. It's got a seaplane hull, and it's got some floats out there. And Stan runs out of, he's got this thing, he's lost one engine, he can't keep it up because it's too hot. So he gets in the water, he's trying to air taxi in, he's calling for help, he gets to the seaplane ramp, he wants some help, and they say, get it in yourself, so it shuts down, runs out of gas, and turns over and sinks. Remember that, Stan?
Except they put a rope around my tail wheel and tried to tow it, and that's what capsized.
Yeah, okay. So you can see we ran into different experiences. I had some pictures, I don't know if I can show them, but one what I wanted to talk about a little bit was the Vertol 76. No, that's a Cheyenne. Can you click it down a little more and maybe come back to that one? One more. That's it. The Vertol, is that the tilt wing? Yeah. That's the Vertol 76. With that, after Bob did the XV-3, the Marine Corps and the Navy thought, well, we should be getting in the V-stall work. Leonard Levasseur from Vertol was doing this VZ2, and there was this VZ4 program also, which was a tilt duck. They were the forerunner to the tilt duck that Stan was flying. This was flown by Leonard, and it's a small airplane, 535 shaft horsepower, I think, something like that. Two collective type props on the front. You tilt the wing over, it's got a prop on the back for pitch and a prop on the tail for yaw control when you're in slow speeds. It has ailerons that are coupled out so you phase it. It had a collective and a throttle. And it was very interesting to fly. For going through transition, if you try to stabilize at each wing angle, you had to be in a minimum climb of 600 feet per minute at a 30-degree wing angle, as an example. You lower the power, and what happens? It would want to topple. Well, luckily, Jack had an ejection seat in it, so you could investigate a lot, and we did. And that was a very good program. The day I flew it, and I was very pleased because that did make me the first active-duty naval aviator to fly in a V-stall. Fred Drinkwater, who was an old classmate of mine, and Jim Whitten from NASA also flew it, so that made us the first 5 to fly it. Later on, Jesse and his gang all got to fly it and get training for their program. Out of that report came a lot of things that I think the Marine Corps read in some cases and didn't read it in other cases. It was going to be horrible aboard a carrier because when you fold all this stuff, it becomes a bunch of claptrap. I mean, have you ever seen this thing fold up and try to get down a ship when we do it with an airplane? Well, I was more concerned in whether we would be able to carry a lot of troops in it or whether we could carry armament in it or what we should do with it. And I wrote my report that way. It wasn't negative, it was positive. I suggested that we go through, like the XC-142 program, another program to evaluate more operational characteristics with a minimum of 3 aircraft, and they did that. And Jesse's going to talk about that. So let's go now to the next picture, if I can. If we still get another slide up. Are they available? Okay, which one is that?
That's the XH-51.
Oh, that's the XH-51A. This is an airplane that we flew at Lockheed. At this time, this is at Paris in 1965 early, where I took it to 277 miles an hour. It stole the Paris Air Show. In fact, the French got so mad at us, they made us put it in the fixed wings area, but that was all right. I flew before the Thunderbirds and after the Blue Angels, so it made it very good. It was a very interesting bird. It did later go out to 302.6 miles per hour when we came back. We didn't have too many problems with it. It has a J60 on the left side. It's got the XH-51A with the Lockheed gyro concept. Now, what is that? That is a rigid rotor. And you have a gyro, which is mechanical, that the pilot processes a spring, and he doesn't know that puts a force on the gyro and gives the gyro a place in space. That, coupled with the rigid rotor, gave it stability and control. The control came from the fact that you completely unload that rotor and you still got control, because at zero lift you're flying on the wings, but the rotor is like ailerons. That's what's wrong with helicopters today. You wouldn't fly an airplane if the wings had hinges that flapped. And that's what you do when you fly a helicopter. The only thing holds them out there is centrifugal force. Now, of course, with stability augmentation, it helps an awful lot, and we developed that, but I don't have time to go into that one. We flew this, Ray flew that. About the biggest problem we had is at about 270 miles an hour, the windshield would want to cave in. A big howl would come up, and we finally got a jump seat in the back. We found out we had negative pressure inside the cockpit, and it scares you a little bit when you have to hold the windshield out, so we got that squared away. It was fantastic. It did do 302.6 miles an hour. It would go further in my mind. We lowered it. I could auto-rotate that thing at 15 miles an hour. It's 16 degrees angle of attack, flying on the jet engine by itself. That is the forerunner of what a compound should be. Full control at zero lift on the rotor. Full control. We went from there then, of course, and won another contract to go to the AH-56, if we could get the next slide. Now, this concept is a little different. Is that the 56?
Yes. Yes.
Yeah. Okay. As you can see, this was quite an airplane also. It was very premature, and you got to remember, Lockheed hadn't built many helicopters. When we got to the XH-51, the rotor, the forerunner of the compound, we looked at it for Navy versions, and we made and certified a Model 286, and it was fully stable. You could fly instruments on it, although we didn't do an IFR certificate. We did that because everybody said it wouldn't work. This is the only helicopter or program I've ever been on where everybody in the world wanted you to fail, except a few of your customers. And they did. They didn't want us in the business. That's very frank, but it's very true. The aircraft itself was a rigid rotor, and they made some changes as we got to this. First, we put a pusher prop on it. It's a beta control. We put a twist grip on where we used to have it like a piston pounder on a chopper on the collective. We had that so that you can control the pitch of the pusher prop, get forward thrust, and you could go to reverse thrust. One of the concerns I first had in looking at the design concepts and when we were doing it was what happens when the engine quits and I'm way out there at high speed with a lot of prop on. That's just like having a lot of collective in. If the engine quits, it's going to drag me down right now. It's going to take the rotor with it. So we developed what we call a negative torque compensation system. And that was mechanical also. There's nothing electronic in this thing now. That was mechanical. When your engine failed, or you cut off the engine, single engine, but just under 4,000 shaft horsepower GE, it would sense your gears. And if it got a negative side on the gear, it would trigger a mechanical thing which would drive your prop back to 8 degrees if you're out to 14 or higher degrees. Why would it do that? That was the best detent for auto rotation. So if you're flying along at high speed and it failed, or you shut your engine off, it would then drive that back. You could actually climb because your rotor was speeding. And I demonstrated this many times. The pusher prop you could take off. The wings you could take off. We had auto rotations with them on and with them off. But the main concept on this thing was its weapons systems, and it was good at it. Now, we had some problems. They all do in the beginning. One of the things we did was increase the weight on this airplane like they've done with the V-22, so that makes it a different bird. On this one, we had to keep the match of the mechanical gyro and the rotor blades and the rotor blade symmetry to keep all those things going in harmony. We didn't do it right because our engineers decided we could save weight by lowering the mass of the gyro and some of the control system, and that changed the polar moment of inertia. So that in given conditions, you could overpower the gyro, and we got what we called a half-P hop. We were investigating that and looking at ways of changing it, which we did with an improved control system. We also had other modes called a reactionless mode and an inverse mode. I have flown a lot of airplanes, and I've flown fixed wings, and I've done flutter tests, and I've done structural tests, but I've never done so much in this one. We were doing hour after hour of stirs at every speed. Stick stirs at 1 cycle per second, 2 cycles per second, 3, both clockwise and counterclockwise. If I had done that in a fully articulate head, I would have busted the head. Just really beat it. In fact, one day with the improved control system, I'm doing 40 knots sideward flight. I'm doing the stick stirs. I kick it out, and I feel things, and thank God, God's been on my side. I feel it. I dump it on the ground at full speed. Luckily, to the way we designed the cockpit and the systems, I went into full reverse, shut off the engine, and hit the rotor brake at the same time, and the blade came down and set right there. So it was very interesting. But that was only because I had overextended the stress on the blades. We put another one back on, went and did the same test, and gone after that. We then went to a mechanical control system, advanced mechanical control system, so we had 2 of them. With this airplane flying, it was guaranteed to do 250 miles an hour. We did 277. It was supposed to carry all kinds of weapons. We fired over 130 tow aircraft, but nobody at this time wanted to go along. You got to remember, we were in the McNamara era where they had total package procurement. We had the Air Force arguing with everybody on missions and roles. I had astronauts come out. I had Barry Goldwater come out. I had General Westmoreland come out. We even had the Director of Army Aviation come out. We had many Air Force people come out. And I'm flying with Barry Goldwater, and I think I made a mistake. I had too much gunnery experience. We're down doing Napa the Earth, and I'm trying to demonstrate to him what it was like when you fired a tow. The weapon system itself had a gunner in the front and the pilot in the back with a helmet gun sight. The gunner could launch onto a target, say at 3,000 meters out there, 2,000 meters, whatever, zap it, leave, come up 4 or 5 miles away, zap back on it, he'd be back on the target, fire the tow missile, and guide it right into there while you're firing your other weapons to protect yourself down low. And Barry Goldwater to me said, Don, what's the length of time for the tow to go from there to there at max range? I said 14 seconds. He says, they'll kill you by then. I said, they won't see you down there. I said, come on up, we'll go do a dive bombing run. I've done a lot of those. I've had my share of combat in doing that. So I took him up, and what you could do with this is with that pusher prop, you could set a prop blade angle, push over to a speed, and you would maintain that speed and have an exact dive angle. Now, what did that mean to me? It meant that I had a constant angle of attack on my missiles and on my weapons. So I wouldn't get trajectory shift. I could come down in a 60-degree dive angle, which I demonstrated, at 160 knots, and it would hold it all the way down until I wanted to pull out. Or I could do it at 180. And at which time, Barry, when we got down, he says, Don, that's an Air Force mission. The other thing we had to do was demonstrate at 160 knots at 3,000 feet. And this is HPO, and indicated airspeed, 2G turns, at 2G turns, 720 degrees, plus or minus 50 feet. Now, I would cheat a little bit on that. I'd start 50 feet above and end 50 feet below. But we demonstrated both to the left and to the right. So it was a fantastic airplane. It's still a good concept. And what I like about it, it's so simplistic. We don't have to tilt anything. We don't have to rotate anything. We don't have to have any electric systems in it. We don't have to have periods of when we don't know whether we're going to have control, because you've got it all the time with that type of a compound. But it requires a rigid rotor. It doesn't necessarily require the gyro system now, but you've got to have the control power so you can unload it and put the weight on the wing. So that's our bird. If there are any questions, I'll be glad to answer them.
Okay. Don, that was an excellent analysis, and I think it is going to stir a lot of interest in the audience, and we'll come to that later. What I'd like to do now is go to a completely different kind of VSTOL flying machine. We've all heard of aircraft, vectored jet lift aircraft like the Harrier, but this is a very different beast that we're talking about. We're talking about the Dornier DO-31 with Drury Wood, and Drury had a fascinating background as an aviator before he got into the VSTOL business. Naval aviator, SETP fellow, basically Mr. Attack aircraft. He flew the old AD Skyraider, the AD-1, which became the A-1 in our service in the Air Force, the A-3D, the A-4D, the F-4D Skyray fighter, U.S. Naval Test Pilot School grad, flew the original N-156, which went two ways. Out of that came the F-5 and the T-38, and made the first flight then with Dornier in the DO-28 STOL. And then, of course, Dornier's STOL work eventually led them up to their STOL aircraft of the present day. And then, of course, got involved in a 10-engine VSTOL airplane, the Dornier 31. So the stick's over in your hands.
Once upon a time and long ago. And incidentally, you may have been the star of the parasite until I got there. I was living in Lancaster, California at that time, working as a technical advisor for the United States Army when I got a letter. I could read the name on the envelope. It was addressed to me, but I couldn't read what was in it. And the letter was in German. So I had to go find someone who could translate it for me. And this old guy looked at it and he read, he said, das ist gut, jawohl, And finally he said, oh, you should take this job. He said, the fat will be running out of your mouth. Well, they also sent me an airline ticket. So I went over there and looked at it, and I think I was fascinated more by the country and the travel experience and all that sort of thing. Then I realized what I was taking on. There had never been a major aircraft program in Germany after World War II until the German government decided to try to fulfill 3 VSTOL requirements because the war was going to be nuclear and somebody had to have some place to land, and so the federal government responded with 3 proposals, one a fighter, one an attack airplane, and one a transport. The attack airplane got so far as a hover rig, and they're so ugly. I'm sure you've all seen pictures of those things. They look like flying jungle gyms. And the fighter itself actually was built and flew sometime, very sleek-looking airplane with engines rotating on the tips. And it actually flew, did some pretty high Mach number, but crashed one day on takeoff because of a faulty gyro. And the pilot was severely injured. The program was canceled. Well, when I first went there, the first flying object that we had was a jungle gym. It had 4 Rolls-Royce engines in it, and then there was a cruciform thing about as big as this stage. In fact, it was larger from side to side, and imagine that as being the same length. And it was an interesting airplane. It had 4 Rolls-Royce engines in it, one on each tip and one in the middle, and a hot pipe that ducted air from these engines to the front and the back, and that was the pitch. The roll was changing the thrust on the 2 outboard engines, and the yaw was actually moving the engines on pivots on the ends. There were not much instruments in it, just 4 temperature gauges. And the fuel gauge, of course, was pretty important because it only had 5 minutes of fuel in it. And I knew that I was in trouble when this tall guy came walking out. His name was Stretch Meyer, and he waved this red flag. You know, and when I saw that, I knew I had 30 seconds to get the thing on the ground. You don't go around, what is this auto-rotate stuff you guys are talking about? Jeez. So I flew that thing a couple of 100 times, and it was used to test the stabilizer for the next airplanes. Well, this took about a period of a year, and when we were in meetings about all of these things, everyone was talking about the airplanes, of course, and every now and then they would stop talking in English for my benefit and switch to German. And so I kept hearing words that I thought I should understand.
That's a bad sign.
You know, like Schleudersitz, ejection seat, Dummkopf. So I went out and looked for a German professor, and I said, I'm going to catch up with this thing. I'm going to know everything that's said at these meetings, especially when they're talking about my body. So I got this German professor, and I went there for a few weeks until he said to me, and I have to prove this, he says, bitte Herr Wood, kommen Sie bitte nicht mehr. I said, don't come back here anymore. I said, why is that then? He said, weil ich habe nie gehört, jemand, das so fürchterlich Deutsch spricht mit so viel Vertrauen. He said, don't come back again. I have never heard anyone speak such bad German with so much confidence. Well, the second test article looked like a bigger jungle gym. It sort of looked like the airplane. Is there a picture of it here anywhere? Did we get a picture of the DO-31?
I don't think we have, no.
We don't have a picture of it?
No.
I sent you one. Well, never mind. Okay, it's a huge airplane, and it has, looks like belly tanks on the tips. When there's 4 engines in each one of these things, and they supply the vertical thrust, of course. Well, this one that we were going to build that looked like the airplane, but it wouldn't go very fast, only had 6 engines in it. And we didn't have to test that very much. It had the stabilizer system, and I should tell you right now, and there are those of you who can appreciate this, that it only had a single axis stability system. One axis, one in each configuration. I kept telling them this was not a good thing to do, that this had no commercial application. And but we had to go through it because that's all there was to it. Well, one day I was about to take off. Now, this has nothing to do with stability, and the 3 engines on each wingtip, there were 6 of them, 3 on each side. And they were all held together with a fairing, and all you could see was just these little holes down there, and there were jet engines about that tall and about that big around. They were plastic from the intake down to the burner section. And a bolt came out of the first engine on the starboard side. That's right, the Air Force guys. And it came out, and it came out of the first engine, the second engine, the third engine, and destroyed them all just as I was lifting off. This upset me.
That's good design.
And so I began to worry about ejection seats, but I didn't need another couple of seconds, and it would have been inverted anyway. They could have just torched it, and it would have been a complete funeral. So after that one, then we had a conventional airplane, which didn't have the lift engines in it. It was just to fly conventionally, and there was a structural test thing, of course. And it was a kiddie car, a real kiddie car. We did have some things to settle, like helicopter pilots like to sit on the right side. What is this, guys? Is this some sort of a macho thing here, you know, which side of the airplane you fly on, you know?
That's how you start.
It's how you start? Oh, okay. All right. I'm not a helicopter guy. Anyway, but they decided this was going to be a transport, so the pilot would sit on the left-hand side. So I was one of the first guys to fly a transport that flew like a helicopter but had a wheel. Now, that was interesting. What also made it very helpful was that there were 2 throttles for the Bristol Pegasus engines, which were underneath the wings, and look about the same as a Harrier. In fact, it was as big as a Harrier, and all the other engines were on 1 throttle, so that you lit off everything at the one time. Actually, I had a great deal of confidence in this airplane, the program, the technology, everything else, right up until the time I started the 10th engine. You know. So the first takeoff we're going to make in transition, the Pegasus engines light off all of the other engines after we get up sufficient power, and the nozzles are supposed to go down like this. And so I put the nozzles down, and it says don't go any further than 68 degrees. I mean, or was it 7, something like that? Because if you put them all the way straight down, then all this hot air is going to come out the front and the back, and we're going to have a big mess down here. So I put it down to what they told me, and I pushed the power up, and we called that flight the Reluctant Dragon. The hot air hit the ground, came back in the Pegasus. the backfiring, fire coming out the ducts, the inlets, the side thing, everything. It was, and then it was awful. I mean, and it was actually bucking down the runway.
When you see it, it's awesome.
It was bad that the reporters were there.
Yeah.
Okay, but I flew that about 48 times, and now here comes the real airplane. And this real airplane was totally finished. I mean, it was ready to fly troops. Have you ever heard of an airplane that will fly backwards at 40 knots and forward at 0.7 Mach number? Beat that. So, one day, after we were able to be in conventional flight, and I had already hovered in this big hover rig, and now we had to put the two things together. And so I approached the airfield with my heart in my throat. Or was it mouth? No, anyway. And I did everything just right, and we landed. And it worked like a charm. We got over 600 flights out of the program. We only had one incident, and that was when we had some NATO inspectors come from the transport section of NATO, the medium transport section. And we were going to demonstrate to them the fact that this might be something that NATO would like to have. And so I came from a conventional flight, translated, and land on a 150-foot platform on the grass, which is smaller than this room. There was a problem. When I started coming down and I hit the point where I felt like I should be able to pull the throttles, I kept on going. And the airplane laid very gently on its belly. Now, all of you pilots know they're going to say, well, he didn't put the gear down, but I did. I had the project engineer sitting there, and I said, 3 green. He says, yeah, 3 green. And we had the cameras and everything else, so we finally pinned it on the landing gear manufacturer.
Thanks very much, Drew.
Now, wait a minute. I'm just not done. Let's get. So anyway, one day we decided, it was called Germany's Parade Horse, and I flew to all the air shows. And one day we took off for Paris to do an air show. And I said, why don't we do some world records here? And so we got the FAI, the Federation of Aeronautics, to
here we go.
Record. Here we go. Here's what it looks like. Oh, look, that's the cockpit. Oh, this is a good shot of it. And then I'll say goodbye. Okay, watch this thing. It's awesome. There come the gear up. Oops, we're going to stop. So anyway, we were going to fly from Munich to Paris, and I thought we would record it. And so out of that flight, we got 5 world records. And the reason why they will never be beaten is because they are for particular classes of airplanes, and no one will ever build another airplane like this.
Thanks very much, Drew. This aircraft is still in existence. If you ever are over in Munich, it's at the Deutsches Museum. It's a very impressive machine to see. Our next speaker, we are pressing on time, and I think in the interest of questions, I'd recommend that you catch the panelists at the bar later or at the pool party. Our next speaker is Jesse Jacobs, and Jesse, of course, once again, is highly distinguished and recognized by this society, a fellow of the society, and he's laboring today under a real problem. He has laryngitis. Now, you have to know Jesse Jacobs to realize what a burden that really is. But if you look at his background, once again, here's a guy who's done just about everything. Flew B-17s in World War II, survived attacks by Messerschmitt 262s, flew F-80s in Korea, Empire Test Pilot School graduate, bomber test pilot, fighter test pilot, B-47, B-52, F-106, F-102, and then got into the XC-142. And Jesse, insofar as he is able to, will give us some comments on the XC-142.
Thank you very much, Jesse.
Yeah, thank you, Dick. I wasn't sure if my voice was even going to make any noise except a croak when I first started. So those of you that know me know that I don't sound normal. But I'm delighted to tell you about the 142. I think I don't know if they have a picture or not, but the airplane was a 4-engine tilt-wing airplane. It was designed to carry an 8,000-pound payload at at a gross weight of 37,500 pounds. And the wing would rotate from 0 to 98 degrees so that you were allowed to hover in a in a tailwind if you needed to. The hover angle was actually about 86 degrees because you got a lift component coming off of it.